So now let's talk about the procedure you're going to use when you do implicit differentiation. So the first step is you're going to differentiate both sides of the equation. And then you're going to collect all terms with a dy dx on one side of the equation by themselves. Step 3, you're going to factor dy dx out. And then finally, you're going to solve for dy dx. So again, this is the procedure you're going to use anytime you do an implicit differentiation problem. So let's look at an example here. Let's put this into practice. I want you to find dy dx given the equation y cubed plus y squared minus 5y minus x squared equals -4. So if you look back at our procedures, the first thing you're going to do is take the derivative of both sides of your equation. So I'm going to take the derivative of both sides. The derivative of the right-hand side. And now we're going to proceed, take the derivative here. So y cubed, it would be 3y squared dy dx. Y squared would be 2y dy dx minus 5 dy dx. The derivative of x squared is 2x. And the derivative of a constant is 0, so you get 0 for the right-hand side of the equation. So then you're going to collect up all of your dy dx terms on one side by themselves. Well, they're on the left side. I just need to move this one on the minus 2x to the other side so that I've isolated the dy dx terms. Minus 5 dy dx equals 2x. And then step 3 in our procedure said to factor out dy dx out of all of these terms on the left-hand side. And then finally, to solve for dy dx, you're going to divide by that thing in the brackets there. So you'll get 2x over 3y squared plus 2y minus 5. And there's my derivative right there.